Let's apply the rational zeros theorem to an example. So let's determine a list of possible rational zeros of f of x equals negative 4x cubed plus x squared plus x plus 6. So we first have to identify the factors of the constant, which is 6, and the factors of the leading coefficient, which is negative 4. So the factors of the constant first, those are our p's. So I could have plus or minus 1, 2, 3, or 6. Those are all the factors of 6, both positive and negative. Now the factors of the leading coefficient. Well, I could have plus or minus 1, plus or minus 2, and plus or minus 4. Now all combinations of the p's over the q's, and we don't have to repeat things. So I'll first do all of the p's over the first q of 1. So I'd have 1, 2, 3, 6. And I'm just going to put a generic plus or minus in front of all those as well. And then I'll move on to the second p, which is the number, the second q, which is the number 2, and put all of the p's over 2 now. So I'd have 1/2, 2 over 2 is 1, and I already have that. 3 over 2 is another possibility, and 6 over 2 is 3, and I already have that. So now I'll move on to the last q of 4, and I'll put all the p's that I have over 4. So I will have 1 over 4, which is 1/4, and then 2 over 4, I already have a 1/2 listed, so I don't need to write it again. I have 3/4, which is new. And then I have 6 over 4, which reduces to 3/2, which I already have listed, so I don't need to do that again either. Now I can go on and continue to understand that what this theorem is telling me is these are all the possible rational zeros of f, and they're all listed here. So I can put them in increasing order maybe, so plus or minus, let's see, 1/4 is the smallest number I have, then 1/2, then I have 3/4, then I have 1, then I have 3/2, and then 2, 3, and 6. Those are all the possible rational zeros. So from the graph, it appears that there's only one number on that list that could possibly be a 0, and that would be 3/2. As you can see, that looks to be the only real 0 that we have is between 1 and 2, so it's possible that is the 3/2. So we know for sure that 4, for example, is not a 0 because it's not on our list above. All right, note the rational zeros theorem doesn't guarantee that f actually has any rational zeros. It simply says they're possibilities. So, but if it does have any rational zeros, they would be on the list that you figure out from all of your p's over q's.